Hi, boys and girls. Welcome to section 7.3, the Pythagorean Theorem. I'm starting off with what I call the prequel because in true reveal form, they went right off a cliff and right away started throwing word problems in this. And so I felt like we needed to have some practice with the Pythagorean Theorem, just regular triangles first, before we start putting ladders against houses. Okay, so this is the prequel. All right, first we need to talk calculators, okay? Because in the Pythagorean theorem, we're going to have the need to use the square root function on whatever calculator we're happening to use. Now, some of you have this TI-30. If this is the calculator you're using, let me show you what you need to do to square root a number. The first thing you do is you type the number in. Like, for example, if I want to find the square root of, say, 23, okay? First turn it on. Then you hit, then you hit the second button right here, because what we're going for is this little square root sign right here, and it's the second function. So first thing you do before you even type in the number, you hit the second button, and then you come down and hit the x squared button. That will give you the square root sign. Then you type in 23 and hit enter. You don't need to put an ending parenthesis like you had to with the really antique TIs. This one will go ahead and just end it for you. Let me make sure I'm telling you the truth. Second square root 23. Yep, there you go. So that's what you would do on the TI-30. You would hit second and this x squared button to get the square root, and then put in the number and hit enter. Okay, but let's say that maybe you're not using a TI-30. Let's say you're relying on the Desmos calculator that comes embedded in the assignment. And I will show you how to do that on that one. Let me pause this and I'll go over to the other screen. Okay, so this is the Desmos. This is the last week's lesson, but this is the Desmos calculator that pops up when you're doing your assignments on Reveal. And the square root function is right here. Okay, that's the square root button. So let's say we want the square root of 23. I believe with this one you type 23 first and then you hit that. Nope. Nope. We're going to hit that first right there, and then we type 23, and then we type equals, and there you have it. Now, with the square root, the directions on all of the assignments are round to the nearest tenth if necessary. Rounding to the nearest tenth means there will be only one number after the decimal. You got to remember how to round here. So, and it's okay if there's no number after the decimal. If it rounds to a whole number, that's fine. You can just write the whole number. But in most cases, it's going to need rounded, and you are going to have a number after the decimal. In this case, this 7 would become an 8 because the 9 is 5 or greater. If it was 0 to 4, then this would have stayed 7. But because this number is 5 or greater, this becomes an 8. So we will be rounding, and I'll do several of those. Now this is the Desmos calculator that comes in the assignment. If you prefer to pull up the Desmos calculator that's available on the internet, you just go to desmos.com and type scientific calculator. I kind of like this one better. It's bigger. You know, you can type the square root of 23, hit enter, and voila, there you've got your answer. So that's if you go to desmos.com. Okay, let's flip back to our assignment now. I passed out the doodle note. You should have this. If you don't have it, will you remind me that I'm supposed to pass out the doodle notes? Because I will want to do that. Here we have the Pythagorean Theorem. The Pythagorean Theorem is for, you're going to want to write this down because this is going to be your cheat sheet on your quiz. All right. The Pythagorean Theorem is for finding a missing side of a right triangle. Now, what's a right triangle? Well, a right triangle is a triangle that has a right angle in it. Now, a triangle can have only one right angle. It cannot have two. But if a triangle does have a right angle in it, then it's called a right triangle, and you can use the Pythagorean theorem on it. Okay, now there are names for the different parts of a right triangle. The longest side and the side opposite the right angle is called the hypotenuse. Don't ask, I don't know why they named it that. It's the most ridiculous name ever. It's always opposite the right angle. Okay? The other two, this pen is annoying me today. The other two sides, the sides that make the right angle, are called the legs. That's a leg and that's a leg. They're always the shorter two sides, so they have the shorter name. The hypotenuse is always the longest side, therefore it has the longest name. Okay? Pythagoras was the inventor of the Pythagorean theorem. He was the Greek dude who invented the Pythagorean theorem. Well, he didn't actually invent it. There's a story behind that. I took a math history class over at UD. Greek dude who claims to have invented the Pythagorean theorem. We'll just say who invented the Pythagorean theorem. We don't have enough room to write all that. The Pythagorean theorem. What actually happened was Pythagoras had this like club that was exclusive. It was kind of odd too because he allowed women in his club. And it was during a time when women weren't normally encouraged to do math, but it was kind of like a math doers club. And Pythagoras did have women in his club. And somebody in the club, although Pythagoras got credit for it, it's possible that he didn't invent the Pythagorean theorem. And in fact, there are evidences that people used the Pythagorean theorem before Pythagoras did. So I guess what he gets credit for is he published the first official proof of it. But my theory is that one of the women probably thought it up and he took credit for it. Yeah, that's it. Anyway, what it says is if you square the legs of a right triangle, all right, and then square the hypotenuse of a right triangle, if you add the two squared legs together, it will equal the squared side of the hypotenuse. Okay, let me show you what I mean. This is the 3, 4, 5 triangle. If you take 3 and square it, that's 3 times 3. You get 9. Here's 9 boxes. Okay, so 3 squared is 9. 9 in that one. 4 squared is 4 times 4, which is 16. And this would be 5 squared. 5 times 5 is 25. And they're saying if you add these two numbers together, you get this one. And it always works, okay? If you square the two legs of a right triangle and add those sums together, it will equal the hypotenuse squared, okay? Let's see. And you can color it, you can color these blue and color these red and then color these purple or do part of them blue and part of them red. This theorem only works on right triangles. Okay. This is example 1, and this is so reveal because they go right to a word problem. Example 1, a right isosceles triangle has legs 6 meters long each. Okay, so let's draw this. We know it's a right triangle, and they said it's isosceles. That means both of the legs are the same length. They're both 6. Find the length of the hypotenuse to the nearest tenth. Okay, so the hypotenuse, the longest side, is what we're trying to solve for. Well, if we use the Pythagorean theorem, we know that 6 squared plus 6 squared has to equal the hypotenuse squared. Okay, that's what we figured out. If you square the leg and you square the other leg and you add them together, it will be equal to this hypotenuse squared. Well, 6 squared is 36, and 6 squared is 36. 36 plus 36 is 72. And so here's where you're going to want to use your square root function. You're going to take the square root of 72. You need to know what the square root of 72 is. And you will get 8 point blah, 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 blah. You will have to round it to the nearest tenth, which is 8.5. Okay, now I'm going to write meters here, but I can tell you right now in Reveal, don't put the units, just put the numbers, Reveal. Okay, let's see. Here's your theorem, all right? And here's what each letter represents. I always say a squared plus b squared equals c squared. It's a pretty easy one to remember. A is a leg, so it would be a leg squared plus the other leg squared is equal to the hypotenuse squared. And I wrote that word out once. I'm not writing it out again. Okay. Now, this first example, we were finding the hypotenuse. That's the easy way to do it. You just have to square the two legs, add them together. They equal the square of the hypotenuse, and then you square root the number. It's simple. When we're missing a leg, it gets a little more complicated, and I'm going to show you both kinds of problems here. When you're missing a leg, what happens is, I'll do it over here. You're going to have x squared, because that's a leg, plus the other leg squared, 8 squared, equals, and now I know the hypotenuse is 13 squared. Okay, so this looks a little different because in the first example we knew both of the legs, but in this one we do not know this leg, but we know this. So how do you solve this? Well, it's similar, but it takes an extra step. Go ahead and leave that x squared for now. 8 squared is 64. And 13 squared, I believe I know off the top of my head, I think it's 169, but let me make sure, just because I screw up when I do things like that. Yes, 169 is right. Okay. Then, in order to get x by itself, we have to treat this like an equation that we're solving for x. We subtract 64 from both sides, and that gives us x squared is equal to, that's 105. Okay. Then we have to, what we say we do is we square root both sides. So I need the square root of 105, and that is approximately 10.2, rounded to the nearest tenth. Okay. So x equals 10.2. And then all that other work should have been done in here, but I wanted to write bigger. Okay. So this is the second page, or the back of your handout. Okay. These are just practice. Find the length of the diagonal. Okay, so what we're going to do is we're going to ignore this triangle, and we're just going to focus on this triangle. If this side's 11, this side is 11. If this side is 4, this side is 4. So we have both of the legs. We have the two sides that make the right angle. So we have the two legs. We go 11 squared plus 4 squared equals that hypotenuse squared. We'll call him x because we don't know what he is. 11 squared is 121. 4 squared is 16 equals x squared. Well, 121 plus 16 is 137 x squared. All right. And I have this all worked out in advance. So this wouldn't be a humongously long video. Okay. This works out to when you take the square root of both sides, square root of that and the square root of that, you get that x is equal to 11.7. That's rounded to the nearest tenth. Okay. Now, one thing you can do is you can use the Pythagorean theorem to tell if you have a right triangle. Here, they've given you side lengths of 8, 10, and 16. And this is actually section 7.4, but we'll go ahead and put it on this note page anyway. You can use the Pythagorean theorem to check to see if it's a right triangle. You know that the legs are the two shortest sides, so our legs must be the 8 and the 10. The hypotenuse is always the longest one, so it's got to be 16. So what you can do is you can go, okay, leg squared plus the other leg squared has to equal the hypotenuse squared. And if this works out and these are equal, then it's a right triangle. If they're not equal, it's not a right triangle. So 8 squared is 64. 10 squared is 100. 16 squared, don't know my 16s off the top of my head. It's 256. All right. 64 plus 100 is 164. And 164 does not equal 256. So those lengths do not make a right triangle. If it had been like 164 equals 164, then yes, it's a right triangle. But because these are different, it's not. Okay. So over here, it says the theorem works both ways. You can find a missing side or you can prove whether or not a right triangle is a right triangle. If a triangle is a right triangle, then a squared plus b squared equals c squared. And if a squared plus b squared equals c squared, then a triangle is a right triangle. So you just basically wrote the same thing twice. The really cool thing about the Pythagorean theorem is that it is the basis for the distance formula. We use the distance formula to find the distance between 2 points on a graph. And I'm not going to ask you to do this anytime soon. This is probably lesson 7.5 or something. But I'll show it to you here. If we have the points 4, negative 3, 1, 2, 3, 4, 1, 2, 3, 4, negative 3, and we also have negative 2, 1. So we would have negative 2, 1, which would be right here. All right. And we want to know the distance between those two. What we can do is we can make it sort of into a right triangle. And excuse my messy lines because you know how hard it is for me to draw straight lines on this thing. All right. And if we want to find that, we can use the Pythagorean theorem to do it because we can find out how long this side is. This side is 1, 2, 3, 4 boxes long. This side is 1, 2, 3, 4, 5, 6 boxes long. And we've got to find this side. So we have the two legs. We have the two sides that make the right angle. So we add those together and square them. And then we want to find the hypotenuse. So 4 squared is 16, 6 squared is 64, and 16 plus 64 is 80. And when we get the square root of 80, so we don't want to know what x squared is, we want to know what x is. So when we square root 80, we get 7.2. That's rounded to the nearest tenth. That's the theme, round to the nearest tenth. Okay, so let's do some sample problems. You've also been given a worksheet, hopefully. If not, please ask me for it because I should have given it to you. And these sample problems are on the worksheet, okay? The first 5 problems are missing legs, and they're very easy to solve because they're missing legs. The hypotenuse ones take an extra step, okay? And this will be good practice with us for rounding too. Okay, because we're missing a hypotenuse, this is pretty straightforward. We're using a squared plus b squared equals c squared, right? So leg squared plus other leg squared equals hypotenuse squared. So we have 13.6 squared plus 7 squared equals c squared, okay? Or x squared. You could put x if you want. Now we need to square these with these. You can either hit that square button or you can just go 13.6 times itself. 13.6 times 13.6, that works too. This gives me 184.96. 7 squared is 49. Adding that to 49 equals, add these two together, 233.96 equals c squared. And always remember your last step is to take the square root of both sides because we don't care what c squared is, we want c. So we need the square root of 233.96. And it gives us a big old long repeating decimal. It gives me 15.29575. It's actually an irrational number, so it goes on forever. But rounding it, since it's 15.29, I'm going to round it to 15.3. Okay, and you got to round it correctly or Reveal's going to mark you wrong. So my fear is that you're going to do all these right and get them all wrong because you didn't round them right. This one is done the same way. 7.8 squared plus 6.7 squared equals x squared or c squared. It's up to you, however you want to do that. Okay, so now we just need to square 7.8. 7.8 squared is 60.84. Added to 6.7 squared is 44.89. You should be writing this down on your worksheet also. These would be good notes for you and good examples. All right, so we add 60.84 to 44.89, and we get 105.73 equals x squared. Last step then is to take the square root of both sides, right? Second button, x squared button, type in 105.73, and rounding, we've got 10.28, so this is going to be 10.3 equals x. Okay, so in Reveal, if this were your problem in Reveal, you would just type in 10.3. Okay. 2 more examples where we're finding the hypotenuse, all right? We're not looking for legs yet. Those are the last 5 problems. So these are all set up basically the same way. You go leg squared plus the other leg squared equals the hypotenuse squared. Okay? 4.3 squared is 18.49. And 7.1 squared is 50.41. equals x squared. Now you add these two together. You get 68.9. Okay. And the last step then is to take the square root of both sides. And that is not right. Typed it in wrong. Second square root, 68.9. That's much better. Okay. And I get that 8.3 is x. So you would type 8.3 in if this were your reveal problem. Okay. Same thing, when we have the legs, it's easy. It's one less step. So we're going to do 15.1 squared plus 9.9 squared equals x squared. 15.1 squared is 228.01 plus 9.9 squared is 98.01. Then we add those two together. And we get 326.02. And now the last step is always to take the square root of the number. 326.02. The square root of that is 18.05. So 18.05 rounds to 18.1. I only have one more example where we're missing the hypotenuse, and then we're going to look at problems that are missing legs. All right, so this one is going to be set up the same way. 7.9 squared plus 9.8 squared equals x squared. And you'll know the legs because they're the two sides that make this right angle. All right, whatever two sides are touching that right angle, those are the legs. They're always the shortest two sides. The hypotenuse is always the longest, and it's across from the right angle. Okay, so I need 7.9 squared, 62.41, and 9.8 squared is 96.04. Okay, we're going to add those together, 62.41, and I get 158.45 equals x squared. And our last step, square root 158.45, and that is 12.58. So that would be 12.6. Okay. So those first five are what to do if you're missing a leg. Okay, and on the practice assignment I made for you over on Reveal, the first five are also missing a leg. Okay, so they're done just like these. But what happens when you're missing the hypotenuse? Oh, I'm sorry, I said that backwards. All of those were missing the hypotenuse. That's the easy ones. Long day. These ones are missing legs. And this takes an extra step when you're missing a leg. Okay, think about it. It's extra work to not have a leg, right? Because you'd like have to hop everywhere. So it would be extra work to be missing a leg, I think, especially like in soccer and stuff. Okay, so remember though, our formula is leg squared plus the other leg squared equals the hypotenuse squared. So when you're filling these numbers in, don't automatically take these two and put them here and here like we were doing before. You can't do that. One of these is an unknown. I don't care which one you make it. You can make it the first one or the second one, but one of them we don't know what it is, so it's got to be an X or an A or a B or something. This is the other leg though, so he can go here, 11.4 squared, and this is the hypotenuse, so he goes over here, 15.2 squared. All right, so now I need 11.4 squared, right, at x squared plus 129.96 equals 231.04. Now here's your extra step, okay? You have to get x by itself before you do any square rooting. So we have to get rid of this 129.96. We do that by subtracting 129.96 from both sides. we're solving for x. Okay, so 236, I was at 231, that was 231. 231.04 minus 129.96 is 101.08. And on this side, we have x squared. Now, notice I don't round yet. Don't round until the end, okay? Now, we want to do the square root of both sides to find out what x is. And second, square root 101.08. Now you can round, okay? I've got 10.05, okay? 10.05, the 5 rounds up and gives me 10.1. Okay, over here, this is the same thing. We have one leg, we are missing the other leg, okay? So, like I said, I don't care which one you make be missing, the first one or the second one. Just remember that you're missing a leg, okay? At 14.4 squared equals 15.5 squared. So I put the leg, here where the leg goes. This is the hypotenuse, so it went over here where the hypotenuse goes, okay? So now we have to do some squaring. 14.4 squared is 207.36. 15.5 squared is 240.25. Here's our extra step. We have to get x by itself, so we subtract 207.36 from both sides of the equation. Now I have x squared on the left and on the right. 240.25 minus 207.36 is 32.89. Okay, and now last step is always to take the square root of both sides. Okay, and I've got 5.73, so that's going to be 5.7 because 3 is not big enough to make 7 become 8. Just a couple more examples. I want you to have plenty of examples to look at when you're working on your assignment. Again, we are missing a leg, so I'm going to show that the leg is missing, but I do have the other leg. 12.7 squared equals 15.6 squared. Remember, you have to square everything. Okay, this is 169 or 161.29. And this is 243. It'll be a miracle if I haven't made a mistake on this. I'm doing this calculator so fast. Here's your extra step. You need to get x by itself. So we subtract 161.29 from both sides. That gives me x squared on the left and on the right. If I did make a mistake somewhere on the calculator, I apologize. That gives me 82.07. And remember, your last step is always to square root. So the square root of 82.07 is 9.05. 9.05 rounds to 9.1. Just 2 more quick examples because I know this is running kind of long. Let's see. Again, we're missing a leg. So we show that a leg is missing. We have the other leg squared and equals the hypotenuse squared. Okay. X squared, 5.7 squared is 32.49. And 210.25. Right. So now, extra step, we have to subtract 32.49 from both sides. And that will give us x squared is equal to 177.76. Take the square root of both sides. And I have that x is equal to 13.33. Well, that's just going to be 1 3. Okay? It doesn't round up. Another 3 will not make that round up. And my final example here is also missing a leg. So I show that I'm missing a leg. I do have one leg. I do have the 5.1. That's a leg. And equals 16. That's our hypotenuse squared. 5.1 squared is 26.01. And 16 squared, you'd think I'd know that off the top of my head, but I don't, 256. Subtract 26.05 from both sides. Gives us x squared is equal to 26.05 to 29.95. That sounds like a price of like a sofa or something. Well, probably sofas are more than that, I would think. You might be able to find one on sale for that. 229.95. Square rooted is the grand finale problem. The answer is 15.16. 6 is bigger than 5. It rounds the 1 to a 2, so we go with 15.2. That, my friends, is the last example. And since I do have students in the room, the secret word is right there. Okay, not going to say it out loud. All right, so that's the end of the Pythagorean, the prequel. Go ahead and do the secret word assignment, and I will see you in class.